So let us first write the definition. What qualifies as the solution? We're going to talk about explicit solution first. Explicit solution of a differential equation. Well, a function defined on a function like phi defined on an interval like I. Okay, so you have a function like phi which is defined on an interval. And suppose it has n derivative with n derivative and all are continuous. If this function satisfies the differential equation, we say that we have an explicit solution for the differential equation. If this function phi satisfies the differential equation, then we say that phi is a solution for the differential equation. Again, recall that in algebra, you learn that if you have an equation and if you have the possible solution, you can check these solutions by plugging those solutions into the left-hand side, right-hand side, and their left and right must be equal to each other. It's exactly the same for a differential equation. Let's go over one example to feel comfortable about what's going on here. So in this example, verify that y equals to 1/16 x to the fourth is a solution of the differential equation y prime equals to x times square root of y. Very good. So this guy is your phi. Put this in. This is your phi. You want to check to see if this function is a solution of differential equation or not. First of all, this guy is defined everywhere. All right. Let's write this down here. Note that the power function y equals to ax to the n is defined everywhere. What do we mean by that? It means that the domain or the interval is negative infinity to positive infinity. It's differentiable. You can take the derivative, the first derivative, there you get 1/16 x to the fourth. The first derivative is 1/16, 4 times x cubed, or the first derivative is 1/4 x cubed. You can take the second derivative. You can take as many derivatives as you want. It's going to be 3/4 x squared. The third derivative is 3/2 x, and you can continue this process. So let us read the definition. It says, hey, a function phi defined on an interval. We have our interval that has n derivatives. Of course, we can continue taking the derivative. And they are all continuous. Of course, they are all in the form of power terms, power functions. all of them are continuous, is a solution of ODE if it satisfies in the ODE. So I is checked, the derivatives are checked, continuity is checked. Now let us check to see if left-hand side and right-hand side of the equation can bear this function. So you have left-hand side, you have right-hand side, left-hand side, right-hand side. What is on the left-hand side? On the left-hand side, you must have the derivative. But what is the derivative? The derivative is 1/4 x cubed. Plug that in on the left-hand side. 1/4 x cubed. Is this guy equal to x times square root of y? So x is x. Square root is square root. Y is 1/16. X to the 4th. Simplify this. You get x times 1/4 x squared. Simplify again. You get 1/4 x to the 3rd. 1/4 x to the 3rd. Left-hand side and the right-hand side, they are equal to each other. So what is the conclusion? So phi, which is defined as y equals to 1/16 x to the 4th, is a solution, explicit solution of the differential equation, which is y prime equals to x times square root of y. Very good. Let's see what's next. Let us talk about the implicit solution. So when you're talking about the solution of a differential equation, you either have explicit solution, the function is explicitly defined, and you just take the derivative and plug that in. Sometimes we end up with implicit solutions. Implicit solutions, it's a relation between variables. So let me write this guy down here. So definition of implicit solution of a differential equation. Well, suppose you have a relation. Let g of x and y equal to 0 be a relation. Like what? Remember, you had relations like this in calculus. For example, if you see g of x and y equal to 0, it might be something like this: x squared plus y squared minus 9 equal to 0. Or it might be x squared plus y equals to 1. Different types of relations between x and y. So suppose you have a relation. Well, we say that g of x and y equal to 0 is an implicit solution of the differential equation on an interval I if you can find at least one explicit function taken out of this implicit relation that satisfies the differential equation. if we can find at least one explicit solution out of g of x and y equal to 0 that satisfies the differential equation. So again, remember that these are the types of implicit relation. It means that your x and y are combined on one side, but when you're talking about explicit solution or explicit function or explicit relation, you have y equals to, for example, x squared. You have y equals to 1 over 16 x to the 4. You have y equals to sine of x. Y explicitly isolated on one side. These are explicit. So give us an example. Very well, example. This example says, well, check if x squared plus y squared equals to 25 is an implicit solution of the differential equation, which is given to us as y prime equals to negative x over y. Very well. Okay. So let me erase this part of the board. So let us read the definition. The implicit solution. The g of x and y equal to 0 is a relation between x and y. We say that this relation is an implicit solution of the differential equation on the interval I if we can find at least one explicit solution out of this relation that satisfies the differential equation. Well, let us go back to algebra. From algebra, we know that, hey, x squared plus y squared equals to 25 can be written explicitly this way. Y squared is 25 minus x squared. Now we take square root of both sides. Y is equal to plus minus square root of 25 minus x squared. So we get 2 explicit relation or function out of x squared plus y squared equals to 25. Okay, very well. So it's this guy that gives us these two explicit solutions. A solution to this differential equation? Well, again, here we have left-hand side. Here we have right-hand side. We have an equation. This equation has left-hand side and it has right-hand side. Left-hand side, right-hand side. So we need to find the derivative. Well, the derivative, what is the derivative here? How do I find the derivative of this x squared plus y squared equals to 25? Well, I passed calculus. I already know how to take the implicit differentiation. Recall that for implicit differentiation, if you have x squared plus y squared equals to 25, the implicit differentiation says, hey, I have 2x dx plus 2y dy equal to 0. I already know this by calculus implicit differentiation. Let me simplify that. Okay, if you simplify, I'm going to write this guy down here for you. You get 2x dx divided by dx plus 2y divided by dx equal to 0 over dx. Dx and dx, they cancel out. You get 2x plus 2y y prime equal to 0. Now, if you bring 2x to the other side, divide by 2y, you get 2y y prime equals to negative 2x, or y prime equals to negative 2x divided by 2y. You can cancel out 2 and 2. So your y prime is equal to negative x divided by y, which is equal to the right-hand side. Okay, so far so good. I don't have any problem with the implicit differentiation. I learned it in calculus, and if I plug that in for left-hand side and right-hand side are equal to each other. I'm happy here. Now, what about your explicit solution? Are they going to be the solution for this differential equation? Of course. If I plug these back into the relation, it's just a simple algebra. They satisfy this relation. So what is the conclusion? Conclusion is x squared plus y squared equals to 25 is an implicit solution to the differential equation y prime equals to negative x over y over the interval I, negative 5 to 5. This is our conclusion. So where did this interval come from? Take a look at your explicit definition. Your explicit definition has a radical in it. Well, you have a radical. Inside the radical, you have 25 minus x squared. This guy cannot be negative. Otherwise, you get an error. So what you're going to do, you're going to take this quantity, 25 minus x squared, and set it greater than equal to 0, or x squared is less than equals to 25, or x is bounded between negative 5 and 5. Okay, so take a look at your differential equation. You have y on the denominator. It means that these radicals can be placed on the denominator. So if I have 5 and negative 5, this radical is going to be 0. You get 0 on the denominator, which is a no. So your I is going to be open, parentheses, 5 and 5. Let us go over more examples. Very well. So in this example, verify that for x squared minus y squared equals to c. C is just a constant. So c is a constant. Is an implicit solution, of the differential equation, which is given to us as y prime minus 4x equal to 0. Then visualize the solutions. Okay. So what do we have here? We have a relation. What is that relation? For x squared minus y squared equals to constant c. Well, to check to see if this relation is an implicit solution for this differential equation, we need the implicit differentiation. Let us find the implicit differentiation. So here you have 8x dx minus 2y dy equal to 0. The derivative of c is equal to 0. Now divide everything by dx. Well, what do we get? We get 8x minus 2y y prime equal to 0. So 2y y prime is equal to 8x, or y prime is equal to 8x over 2y, or y prime is equal to 4x divided by y. Okay, well, this is what I got from the implicit differentiation. Now, substitute in the differential equation. Left-hand side, right-hand side. Your left-hand side of the differential equation is given to us as y prime minus 4x. So this is the left-hand side and right-hand side. For the left-hand side, I have y times y prime, y times y prime, minus 4x. On the right-hand side, I have 0. Are they equal to each other? Well, on the left-hand side, I have y times y prime. What is y? Well, I don't need to write y explicitly because I found the implicit differentiation. I have y times 4x divided by y minus 4x. I just substitute 4x divided by y for y prime. So as you can see, you can cancel out y and y. You're left with 4x minus 4x, which is 0. They are equal to each other. Very good. So far, so good. Okay. Now, if you write y explicitly in terms of c and x, then using algebra, basic algebra, you can double check that it satisfies the relation. Now, how do you visualize the solution? To visualize the solution, we're going to plug in different values for c, and later on we're going to use technology. Let us plug different values for c. Okay, c can be 0, all right? So if c is 0, you get 4x squared minus y squared equal to 0, or y squared is equal to 4x squared, or y is plus minus 2x. 2 lines. Two lines. So if c is equal to 0, I get 2 lines. One of them is increasing, the other one is decreasing. Suppose c is equal to 1. Suppose c is equal to negative 1, and so on. If c is equal to 1, you get 4x squared minus y squared equals to 1. So it means that you have a relation between x and y. If c is equal to -1, you get 4x squared minus y squared equals to -1. You can just isolate y on one side and visualize this as well. If you have time, plug in more values for your c. But eventually, they're going to use technology to visualize everything. Here you can write it as y equals to, well, plus minus square root of 4x squared minus 1. Y is equal to plus minus square root of 4x squared plus 1, and the rest of the solutions. So what do we have here? We have a family of solutions. It's not just one solution. You have a family of solutions. Family of solutions. Now let us use technology to feel more comfortable about the solution of differential equation. So let's use Desmos and graph these. So remember that one of them was y equals to 2x, the other one was y equals to -2x. Then you had y equals to positive square root of, well, 4x squared minus 1. You had y equals to negative square root of 4x squared minus 1. And you can continue this process. You can plug in the rest of them. Y equals to square root of 4x squared plus 1. Y equals to negative square root of 4x squared plus 1, and the rest of the solutions. So we can visualize the solution, the family of the solutions for this differential equation. This way, if you have time, plug in more values for your c, and then graph the rest of them. Okay, give us another example. This example says, verify that well, x equals to c sub 1 cosine 4t, and another function x equals to c sub 2 sine of 4t are solutions of the differential equation, the second derivative of x plus 16x equal to 0. And then there is this question: is the linear combination of c1 cosine 40 and c2 sine 40 also a solution? Okay. So I have two possible solutions. One of them is x equals to c1 cosine 40. Let us check this one first. So let us check. If x equals to C1 cosine 4t, a solution. So left-hand side, right-hand side, the left-hand side must be equal to the right-hand side of the differential equation. So this is your differential equation. On the left-hand side, you have the second derivative of x plus 16x, and on the right-hand side, I have 0. So x is equal to C1, which is just a constant, cosine 4t. So let us find the derivative. Recall that if x is equal to C1 cosine 4t, the first derivative is equal to negative 4C1 sine of 4t using the chain rule. Applying chain rule again, you get the second derivative as negative 16C1 cosine 4t, chain rule again. So the second derivative of x is given here. Substitute that. What do we get? We get negative 16C1 cosine 4t plus 16 times x. But what is x? X is C1 cosine 4t. C1 cosine 4t. So they are obviously opposite of each other. So the sum is nothing but 0. These two are opposite of each other. So the sum is 0. We're good. We're happy about x equals to c sub 1 cosine 4t. Now let us check the second solution. X equals to c sub 2 sine of 4t. Now let us check if x equals to c sub 2 sine of 4t, a solution of the differential equation or not. Again, left-hand side and right-hand side. Well, on the left-hand side, we have the differential equation, the second derivative of x plus 16x. We want to know if this guy is equal to 0 or not. Again, recall that from elementary calculus. When x is equal to c sub 2 sine of 4t, the derivative of x is 4c2 cosine 4t, and the second derivative of x is negative 16 c sub 2 sine of 4t. Well, do the substitution. This is the second derivative that we have. Substitute that for the second derivative. You get negative 16 c2 sine 4t plus 16 times x. But what is x? X is c2 sine of 4t. Obviously, these two are opposite of each other. It's equal to 0 and left-hand side and right-hand side are equal to each other. Are opposite. So the sum is 0. So we just verified that these two are the solution for this differential equation. Note that you can change C1, you can change C2, and you can get a family of solutions. Note that we can change the constants C sub 1 and C sub 2 and get the solutions, other solutions of the differential equation, the second derivative of x plus 16x equal to 0. And like before, we can use Desmos and graph the solution. We can also graph these solutions. So how do we answer this question? Is the linear combination of the solutions also a solution? Well, let us check it. What is a linear combination of these two solutions? Remember that if you have two terms, in algebra, we learned that. In algebra, we learned that if we have two terms, like px and qx, the linear combination is, for example, C1 px plus C2 qx. C1 and C2 are just numbers. This is called the linear combination. Well, I already have C1 and C2, so I just need to add these together. The linear combination of these two solutions is C1 cosine 40 plus C2 sine 40. This is a new set of solutions. You can call it X. So is this a solution for the differential equation? Well, you have left-hand side, you have right-hand side. Well, on the left-hand side, you have the second derivative plus 16x. So the second derivative plus 16x is equal to 0 or not? Well, you have your x. Now start taking the derivative. I'm going to write this guy down here for you. I need a little bit of more space. From x to be C1 cosine 40 plus C2 sine 40, the first derivative is equal to, well, you already have the second derivative. Why not using it? So the second derivative of, well, x equals to C1 cosine 40 is equal to negative 16 C1 cosine 40. Plus, now the second derivative of C2 sine 40 is negative 16. Negative 16 C2 sine 40. So this is the second derivative. We found the second derivative. The second derivative is just negative 16 C1 cosine 40 minus 16 C2 sine 40 plus 16x. What is x? X is C1 cosine 40 plus C2 sine 40. Distribute 16 into parentheses, you get 4 terms. They are opposite into each other, so it's equal to 0. So we just showed that the linear combination of the solutions is also a solution. So the answer is yes. So far we talked about the family of the solutions. If you don't have any parameter, we call it a particular solution for the differential equation. There you go. Example. Verify that y equals to, so here we are defining a piecewise defined function. If x is negative, then we have minus x to the fourth, and if x is larger than or equal to 0, we get x to the fourth is a particular solution. What's the meaning of that? It has no parameter, or C1, C2, C3, and so on. Is a particular solution of the differential equation xy prime minus 4y equal to 0 on the interval negative infinity to positive infinity. Very well. So how do we verify that? You have a piecewise defined function. Note that y equals to, if x is negative, negative x to the fourth, and if x is larger than equal to 0, x to the fourth is a piecewise defined function. So as you can see in your differential equation, you have left-hand side, right-hand side. On the left-hand side of the differential equation and right-hand side of differential equation, you have the following. You get x, y prime minus 4y. Is this guy equal to 0? If I plug in the derivative of y. So what is the derivative of y? The derivative of y is equal to, if x is negative, then I have negative 4x cubed. And if x is larger than or equal to 0, I get 4x cubed. So I'm going to check each one of these separately. If x is negative, what are we going to use? We're going to use negative 4x cubed as the derivative and negative x to the fourth as the y itself. So you get x times the derivative, negative 4x cubed minus 4, and for my y, I'm going to use the negative x to the fourth. Well, here you get negative 4x to the fourth plus 4x to the fourth. They are opposite to each other. These two are equal. What if my x is larger than or equal to 0? If x is larger than equal to 0, I'm going to use 4x cubed and positive x to the fourth. Left hand side, right hand side. Very well, I get x, y prime minus 4y is this guy equals to 0. X is an x. Y prime is 4x cubed. Minus 4 is 4 times y, which is x to the fourth. Well, what do you have? You have 4x to the fourth minus 4x to the fourth. They are opposite to each other. It's 0, so they are equal to each other. So what's the conclusion? The conclusion is y equals to, if x is negative, negative x to the fourth. If x is larger than equal to 0, x to the fourth is a solution of the differential equation, which is x, y prime minus 4y equal to 0. This is our conclusion here.